Today I'm going to be solving a really beautiful problem from the Putnam exam competition. Let's dive straight in. So this is the problem that we have here. It might be a little bit small to read, so I'll just zoom in. But it says a clock's minute hand has length 4 and its hour hand has length 3. What is the distance between the tips at the moment when it is increasing most rapidly? Now, I'm going to show you two different solutions to this. You might read this question and have come up with maybe like an intuitive way to solve this, and there is actually a really quick 30-second solution for this, but I'm going to show you the longer one first, and then at the end I'll show you how you could have just spotted this straight away, the answer to this problem straight away. As with any question, if we're going to be solving this, I kind of like to draw what's going on, get a little bit of a diagram going. So we have a clock, so let's do a clock here, and we have a minute hand. So let's just assume that we have a minute hand here, and then we've got a hour hand, and it's saying that it's about 4 o'clock. Okay, so we know that the clock's minute hand has length 4, so this would be 4 here, and we know that the hour hand has length 3, so that would be 3 here. Now, obviously I've drawn this with arrows to denote the clock itself, but what we could do is we could draw this geometrically so we can see how it maps out mathematically, I guess. So we'll draw an identical clock, which is an oval clock this time. I'll do a circle, and instead of having the arrows here, we'll just say we'll do something a little bit like this. So assume that's the center of the circle, and we have this here. We can actually draw a really nice triangle inside, which is essentially exactly what I've just done here, but I've drawn it nice and neat. So like we said, this is length 4, this was length 3, and for the purpose of the video we'll call this angle here theta, because this angle theta looks at the difference, the angle between the minute hand and the hour hand, and so we can see at what point that's changing, and yeah, hopefully come to a solution for this problem. So now that we've drawn out this clock here, the problem itself is saying, well, what is the distance between the tips? So tip here, so what's the distance between these two at the moment when it's increasing most rapidly? You might see the phrase most rapidly and think, okay, we're gonna have to do something with differentials. And yes, we are gonna have to do something with differentials, and I'll just write that down before we look at the geometry. So I'll put increasing most rapidly, and I'm just going to say differentials. If I can spell differentials, there we go. Yeah, and I'm just going to move this up here. Now, of course, this is me solving the problem out of pure joy and loving mathematics, but if you were to do this in an exam, not sure whether the examiner would appreciate this notation here, this kind of written out thought, but I'm putting it in this video because, yeah, we're going to be doing some differentiating. Now what I'm going to do is just draw out a triangle, just to remind you of a rule called the cosine rule, which is what we're going to exploit here. So I will draw out a triangle. And you may remember this if you're from the UK, you may remember this from GCSEs or A-levels, but the cosine rule says if we have a triangle with A, B, C as the edges, and then lengths lowercase b, lowercase a, c, and we have an angle here, theta, then by the cosine rule, we have that a squared equals b squared plus c squared minus 2bc cosine of theta. And so in our example, we just substitute in what our values here were. So we had this value here, so b would be 3. Then we'd have c would be 4. And then our a here would be a constant that we define. So let's call this x in here. Now, just to make this nicer to follow, I'm going to basically just draw a triangle again, just to show you how this applies to our situation. So I'm going to just copy this triangle. Again, I quite like to walk through things in detail just so you can understand what's going on. because I appreciate in mathematics, if you miss the tiniest thing out, then it can be very easy to get overwhelmed with everything and not know what's just happened. So I'm trying to go through things very slowly and delicately. So this here would be a 3. This would be 4. This would be our theta, just looking at what we have set up in here. Now I realise that's kind of flipped, but it's essentially the same. It's kind of like a flip triangle. And this would be our x in here. So for this, we would have the x squared. Well, what would that equal? It would be 3 squared plus 4 squared minus 2 lots of, what was b? B's 3 times 4 times cosine of theta. So equating this, we would have 9 plus 16, which is 25. So this would be 25. Then we'd have 2 times 3, which is 6, times 4, which is 24. So that would be minus 24 cosine of theta. And that's what x is. And then we can simply say, well, given that x squared is this, we just take the square root and we end up with this, 25 minus 24 cosine theta. Now, this x here, I realise that I just called it x, but actually this is a really important property, and what it denotes is the distance between the tips. So, like we mentioned, if we look at our clock diagram, we have one tip here, one tip here, and the x is the distance between those tips. And that's what's mentioned in the question. So the distance between the tips. So we have x, we have the distance between the tips, and I'm just going to write that here. So this is the distance between tips. And what we're asked is, okay, well, what is the distance between the tips at the moment when it's increasing most rapidly? So now we're going to do some differentiation. So if we're interested in looking at when x is increasing most rapidly, then it makes sense to do a differentiation with respect to time. So we would have dx by dt. Well, what would this be? This would be, well, we have x in terms of theta, so we would have dx by d theta multiplied by d theta by dt. Now this is none other than the chain rule, which hopefully you have come across. But if not, let me know in the comments and I'll send some resources over for those of you that haven't come across the chain rule before. It's worth mentioning that we have this d theta by dt here, but this is actually a constant. And the reason for that is because we have basically both of these hands, they're rotating uniformly with constant angular velocities. And so this here is simply a constant. So we don't need to worry too much about this. This is just kind of writing it as like a C value. And we'll see if we need to equate it or calculate it later. What we're interested in is this dx by d theta, because we have this form for x. We know we have x in terms of theta. And so calculating this should be relatively straightforward because we have this really nice expression for x here. So let's do that then. I will put calculating dx by d theta. Okay, so I'll just put here for the sake of the video that x is 25 minus 24 cosine of theta to the half. And so if we were to differentiate this, so dx by d theta, well, then this would be, we'd take this power and we'd multiply. So we'd have a half multiplied by everything that was already there, multiplied by the differential of the theta in here. So we would have a half multiplied by, well, we'd have minus 24. Now it would actually be minus 24 multiplied by minus sine theta, because the differential of cosine theta is minus. So this would then become a plus. So we would have a half times by 24 sine theta, all multiplied by 25 minus 24 cosine theta. And what do we do when we differentiate? Well, we just drop this power. So that's now a half. Perfect. So from this, we can say, well, the rate of increase would be dx by dt, which would equal all of this. So we would have 12 sine theta multiplied by 25 minus 24 cosine theta minus a half. And then, of course, we're multiplying by d theta by dt. So that's d theta by dt. And again, this entire thing here is the rate of increase. Okay, we've calculated the rate of increase, but because we're looking at the point at which it's increasing most rapidly, what we're actually interested in finding is the maximum rate of increase. And so for that, we need to differentiate this one more time. I'll write that down. To find the max rate of increase, then we need d squared x by dt squared. We of course need to find the max rate of increase, which is this here, and I'm going to write out what this is going to look like in terms of differentials, because obviously we had the chain rule here, which is fine for the first order differential, but then we're going to want to differentiate again, and this looks slightly different for that case. So we would end up with d squared x of dt squared. Well, this would be the second differential of x with respect to theta, all multiplied by d theta dt all squared, plus dx by d theta multiplied by the double differential of theta with respect to t. Okay, now this is just taking the chain rule here, differentiating again, and then using the product rule, and this is what we get. So what can we actually calculate in here? Well, we already know what what did we have? We already know what dx by d theta is. So we know what this is. That's just this here. And we can also calculate what, if we were to differentiate this again, so this here, differentiate it again with respect to theta, well, we can calculate that, and that's given here. We know that this is just a constant, like we mentioned. Did we mention it? I just said out loud. This is a constant, but because this is a constant, that means this must be 0. So this entire term goes. Interesting. Okay. So what we're actually left with, and I'll just put, because d theta by dt is a constant, d squared x by dt squared is simply this here. Okay, perfect. So what we can do is we can take this in here and we can just differentiate this again. So I'm going to copy that just so we can see it below, and we'll differentiate it again. Cool. So pop that there, and I'll say given this, then we know we can calculate what d squared of x d theta squared is. So let's take this step by step, because we obviously have two parts in here and we're going to need to handle those appropriately. So firstly, what we'll do is we'll handle what's inside here. So we would end up with, well, we'd have 12 sine theta, which is just this out front here. That would be multiplied by minus a half from the power, but then we'd also have this all multiplied by the differential of this inside here, which is going to be 24 sine theta, because minus cosine theta differentiated is sine theta. So this would be all multiplied by 24 sine theta. And then all of that would be multiplied by this, but we drop the power in here. So that would be all multiplied by 25 minus 24 cosine theta minus 3/2. And we'll tidy this up in just a moment. But the next thing we can do is we can leave this part alone and we can differentiate this. So this would just be plus, well, sine theta differentiated is cosine theta. So this would just be 12 cosine theta all multiplied by 25 minus 24 cosine theta minus a half. So of course this in here is what we have here. So we therefore know, well, d squared of x by dt squared, which is what we're looking at, we're going to find the maximum rate of increase. This is of course when this equals 0. So I will just write that out before we simplify things. So we can say the maximum, the max rate of increase is when d squared x by dt squared is equal to 0. Now we know that this is a constant and it cannot be 0 because of the way that the clock is moving. So this is not 0, so we can multiply that out. And we can simply just get that this here must be equal to 0, because we know that this is equal to 0, and if that's equal to 0, so if this entire thing is equal to 0, then we can just multiply this up on this side, and therefore we're just left with this there. Cool. So the max rate of increase is when the second differential of x with respect to t is 0, but it's also when the second differential of x with respect to theta is also 0. So essentially we just need to be taking all of this in here and setting it equal to 0. So let's do that. So when d squared x d theta squared is equal to 0, we end up with, let's have a look. So we'd have the 12s would cancel. So this 12 would cancel with this 12. Okay, so we'd then end up with, we'd have on one side, we'd have minus a half times 24. So that would be minus 12 sine squared theta. Now we have this term here and this term here. So we can essentially kind of multiply and clean things up, because all we need to do is just multiply one side by this to the power of half, then this would just be 1, and then this would be 1 here, plus cosine theta, all multiplied by 25 minus 24 cosine theta, close brackets, which equals 0. And again, we could just move this over, so we'd end up with cosine theta, well, we'd have 25 cosine theta minus 24 cosine squared theta equals, we'd have 12 sine squared theta, but if you remember from trigonometry, sine squared theta plus cosine squared theta equals 1. So we can use that and say, well, sine squared theta therefore must equal 1 minus cosine squared theta. God, there's so many words in this. 1 minus cosine squared theta. Okay. So then what we actually end up with is, this is the same, but we'd have 12 minus 12 cosine squared theta. So all of this, we would take the minus 24 cosine squared theta on this side, the minus, add it, so we'd end up with 25 cosine minus 12 cosine squared theta minus 12 equals 0. Okay, we can move this over again and move it around. So actually this is 12 cosine squared theta minus 25 cosine theta plus 12 equals 0. Oh, we're getting there with this problem. Now you might notice we can factorise this, and this could be factorised as 3 cosine of theta minus 4 multiplied by 4 cosine of theta minus 3 equals 0. And feel free to just verify that on your end if you are interested. Okay, so from this we can conclude, okay, well then cos theta, well, it must equal either 4 over 3 because of this factor here. It's either 4 over 3 or it's 3 over 4 from this here. But of course we know that cosine theta must be less than 1, and so we take this value. So I'll just take this as cosine theta has got to be less than or equal to 1. Okay, so we finally got to the point at which we know when the maximum is. So if we go back to the question initially, we want to find the distance between the tips at the moment when it's increasing most rapidly. So we know that this is the point at which it's increasing most rapidly. It's at cosine theta equals 3/4. Okay, so we know this. We know that's the time at which it's maximum. So let's now calculate the distance, which should be super simple to do because we already calculated what x was, and it's this in here. Okay, now I'm going to copy this, and we're reaching the end of the of the solution. So I'll just put, we know x is this, and so we can substitute in. So we can say, well then x is 25 minus 24 multiplied by cosine of theta, which is 3/4, all of this to the power of a half. Now this is just 25 minus, now 24, 3/4 of 24 is 18, I believe, because that's 6 goes into 4. So that's 3 times 6, 18. This is 18. And I'll have that to half there. 25 minus 18 is 7. And so we end up with the answer that is x equals the square root of 7. And we finally made it. We finally got to the solution. We finally got there in the end. So that is how we solve this problem. Now, I realise that I go through the problem and I talk in a lot of detail about how we get to different steps, and I want it to be really, really detailed, but obviously this would be different in the exam. But just to recap, essentially what we're able to do is we're able to use a bit of geometry to calculate what x is. We can use cosine rule, which is what we did here. Use cosine rule to find a formula for x. We know that we're looking at when the distance between these tips, so the distance was x, the distance between, well, the x value, should we say, the distance between the tips at the moment when it's increasing most rapidly. So we calculate some differentials to, figure this out. And that is what we're able to do. We're able to find initially what we find is the distance between the tips, like we mentioned, then we find the rate of increase, and then of course we want to find the maximum rate of increase, which is when we have this equals to 0. And that's what we do. We calculate that and we find the answer. Now, I mentioned at the start of the video there's a really simple solution to this that takes 30 seconds, and I'm going to show you it now. Now, for the sake of the video and the length of the video, I'm just going to show you it really quickly here and just copy it. The trick is to think of the minute hand as frozen, as if it's just frozen, I guess, in time on the clock itself. So you think of it as frozen. So this is the minute hand here. Now, if you think of the minute hand as frozen, then basically what you can deduce is that the distance, so the distance between the minute hand and the hour hand here, this distance is increasing most rapidly, like I've put here, when the triangle, so this triangle here, makes a 90 degrees angle with the clock itself. So when the triangle itself makes a 90 degrees angle in here, and it's really that simple. It's really as simple as a bit of Pythagoras and just taking the clock and saying, well, if this is a right angle here, we have 3, we have 4, then we know that x here. So we would end up with, well, x is just 4 squared minus 3 squared, which is 16, minus 9, which gives you 7. Sorry, I should say that's x squared. And therefore x is the square root of 7. And so the answer could have, if you saw it and you spotted it and you thought about it in this way, you could quite literally have answered it in 30 seconds and skipped out all of this extra calculation. But like I say in all my videos, I love showing the really long ways that you can solve things, because it might not have been obvious to everybody. But that was the video. I hope you enjoyed it. If you have any more questions that you want me to answer on my channel, then please let me know. Thank you so much for watching, and I'll see you all in the next one.